Hello and welcome to Noel's Retro Lab. Today we're going to try a different format. I call it a quick fix. These are for repairs that don't really warrant a whole episode, but they have some interesting tidbits that would make for what I hope would be some interesting videos. So let's try that today with an Amstrad CPC 6128 that I was restoring that has some really annoying, breakable, tiny tracks. So this is the board of the Amstrad CPC 6128 that I was repairing, and this was one of those that had a major short, so I would plug in the power supply and it wouldn't even give the full 5 volts, it would just be shorted, and I couldn't really find it. Everything was sort of warming up, there wasn't any single thing. I did check that the Z80 and the gate array were working correctly because those were socketed, so it was pretty easy. So I started pulling out RAM chips, which were the most likely culprits, and yeah, the short was dropping, but it wasn't any single one of them. So actually I suspect that all of them were totally fried, and then that wasn't enough. So I ended up pulling out both ROMs, and actually one of the ROMs was completely shorted. So one of them was definitely bad. The other one I'm not really sure. So I'm going to try to pan the camera a little bit, and there you go. That's everything I pulled out of the board. So that was a lot of desoldering and a lot of future socket soldering in my future. Actually, I already started, as you can see. And actually, that wasn't all of it. Now that I think about it, I also removed those because they were getting extra warm for some reason. I don't know why. Then I checked them, and they were totally fine. Those are some discrete logic, like 74 logic. So I was able to check them in the EEPROM, they were fine. And at this point, I know that the Z80 is working and the gate array is working. So I thought, okay, even without the RAM here and without the ROM there, I can plug in a detonator with a diagnostics ROM, or just this is the fancy word for the RAM memory test, and at least I should be able to see it fail, right? Let's plug it in and see right now what I'm seeing. So I'm going to hold this button down while I turn it on, and what we get initially is nothing. And then I notice that if I reset it, we start getting things like this, which this actually looks an awful lot like that regular gray screen that you get in Amstrad CPCs with bad RAM. And then if I hold again the reset, the test and reset, sometimes I even manage, there you go, I managed to get some weird colors. I expect to see some red colors, but not there, not that layout at all. So I was really puzzled until I discovered what happened here, and that's why I thought it would be interesting to make this quick fix video. Before we get started, I'd like to thank PCBWay for sponsoring this episode. PCBWay offers high-quality custom PCB manufacturing, which is something I'm relying more and more every day for my own projects. One of my favorite features of their site is their community projects, where people can share projects and you can order them with a single click. I definitely recommend checking them out at PCBWay.com. So first of all, I did mention this earlier, but the voltages are fine now that I have removed all those faulty chips. So I suspect that a lot of those were faulty, but now the voltages seem to be fine. They're always lower in an Amstrad CPC than you would expect. I think it's only like 4.3 or 4.4 volts, but that's apparently normal. But the RAM test should work just fine with the Z80 and the gate array and the CRT controller, which is this one over here. And obviously, the bus is working and the address bus working and things like that. So I looked at it with the oscilloscope, a bunch of things, and looked at the buses, and I managed to convince myself that the Z80 is working correctly, or actually, well, I knew it was working correctly because I tried it on a different computer, but that is actually reading the data correctly from the detonator, the ROM that we have stored in there. So that's working okay and is doing the right activity. It's just like it doesn't seem to be initializing the CRT controller correctly. And I puzzled over this a little bit and looked at the diagram, at the schematics, to see if there was any kind of logic in between the Z80 and this one. Maybe some of these 74 logic, it's some AND gate or something that is faulty and it was causing the wrong signals to arrive here. Actually, that's why I replaced this one, because IORQ and read and write signals get ANDed together over here, and then those are sent to the enable of the CRT. So I thought, well, maybe that's it. No, that wasn't it. So here's what I found. Apart from a few control signals, the CRT controller has full access to the data bus. That's how it communicates with a Z80. So I started tracing those buses just to make sure that there was correct connectivity. The data bus are lines 26 through 33. And by the way, that is one of the awesome features of the Amstrad CPC board. Let's see, can we zoom in? Is they're numbered. The pins are numbered every 5. That is so useful. I hate the ones that don't have any numberings and you say like 32 and you have to start counting from there all the time. So I love that feature. In here, the data bus is from 26 to 33. Correct, yes. So that would be this one. See how quickly we get there? And then for the data bus, what I can use is I can use the bits directly in the memory slots, since the Z80 unfortunately has the buses all mixed up. So I'll do it in here. So let's see, does that correspond to this one? There you go. Okay. So move to the next one. Yes, yes, yes. It's fine. It's fine. It's fine. And oops. So that is data line 0. And it's not just here, but if you go to data line 0 and the Z80, that's in 14. See how quickly it is to get it, and nothing. But if we go to D1, 15, right there. But 14, there is no connection. So what happened? So what I did is I started tracing where D0 goes from here, and it goes to the ROM here, and it goes to the ROM here, and then splits, and it goes to the RAMs. So you can go from 14, and there you go. That's the one. And you go there, and that's fine. And then as you're tracing the board, here is D0. This one should be connected to this one. And uh-oh, there you go. Because this was splitting somewhere, I don't know, before or after going to the, actually probably before, it was splitting here and doing all of these. And then it was going here and then going to the CRT controller. So what happened? Why did we lose connection right here? So I've already socketed this, but I'll show you a picture of how this was before. So before I put the socket, I noticed this tiny little damaged eyelet, and I didn't think much of it. It's like, yeah, I took it out. I thought I did a pretty reasonable job. I didn't pull any pads. I didn't do anything like that, but I damaged, apparently, that eyelet just enough that that thin trace going down from it lost connectivity. And the reason I even put this socket back on is I thought, you know what? It's so tiny that once I solder this, the flow of the solder from the other side will make the connection, but no, it doesn't. It didn't make the connection. So we need to fix that. So how do we fix it? We just need to make a connection between pin 12 right there to that via right there. So those two should be connected. And we can just do that by soldering a thin wire right there, and that should fix it. There we go. That should be good. Sometimes those short cables are actually more complicated to put in place than longer cables. So I end up giving them a little bend. Otherwise, they're just so short that the whole wire heats up too much and the plastic comes, melts and comes undone. So I think this is good. I don't see any short. So let's go ahead and actually check for continuity and see if we have the full connection now. Okay, so now we should have 11 here, making connection to there we go. And we should be able to go all the way to, was it 33? Right there, yes. And all the way to the Z80, perfect. So now D0 really is connected all the way down to the CRT controller. So that's awesome. Let's give this a try. So we still have the same setup, the detonator with the RAM test, and none of the RAM or the ROM for now. So if all goes well, we should see the result of the test failing all the RAM. And the answer is Oh wait, I need to press this while I press the button. There we go. That's it. So we have the failing test with the red bars right there. And I don't know why it's changing, but that looks much better. So we can put the RAM back in place now. Okay, I've loaded it up with RAM, and this is the lower bank. So that's the bank that gets used in the memory test. So let's see what we get now. I need to press that button. And oh. So this tells us that looks like 2 of the chips are working and the rest are all failing. So those 2, I think those are the high ones or the low, I forget which ones. I believe they correspond to those 2 seem to be fine. Those all seem to be failing, which is very suspicious. So I'm saying it's very suspicious for 2 different reasons. First of all, I believe they're all working. I could believe that maybe one of them is not working, but not that 6 out of the 8. And coincidentally, the bottom 6 are not working. So what is most likely happening here is the same thing that happened here. So let's look at this bank over here, which we haven't even put socket. So we can actually see the traces very well. I'm going to zoom in all I can. So in a bank of RAM chips like this, there's a lot of shared pins. For example, the address pins for all of them, they're all the same. The data out, that's one of the few things that is different. The RAS and CAS signals are also the same to all of them. And we can see that just by following the track. So you see there's the islet there. So let's see, what are we looking at? So 13, for example, is address 6. Address bit 6 in the bus comes here, the track comes here, and it comes to this same connector on the next RAM chip. And then it comes down to the next one. And then it comes down to the next one. It comes down all the way down to here, and then obviously from here, it doesn't need to go any further. And then this column has the same kind of thing. So if you check continuity, we can select that one, and you can see it's connected, it's connected, it's connected, it's connected, it's connected. All of them are connected as they should. Now, whenever you see that a bank in an Amstrad, because they're laid out this way, stops working at a certain point down, chances are one of those little tracks is broken. And unfortunately, it's very easy to break them. I mean, I took this out, I thought pretty carefully. I didn't pull any of the pads or anything like that. But as it happens there, I mean, maybe one of those guys is the track is broken in there, and we may have to do the same kind of fixing. So let's do some very quick checks. The quick way to check this is just to check the top one and the bottom one. If those are connected, then chances are all the ones in the middle are connected. Yeah, so that was CAS. The next one should not be connected because that's data out. So that's the thing that is individual to each of them. And then we start with the addresses for the rest of the, oh, wow. I was gonna say for the rest of the side, but look at that right away. That one is not working. And yeah. Oh, okay. Wow, we found the first try. So it's connected for those 2, and then the track is broken and it doesn't go to this one. So that's why we're seeing green in there and red in those. So we know that the first one, so A6, the same one that I was looking over here, it's missing the connection right here. Let's check the rest really quickly, just in case. So next one, good. Oh, another one, wow. So this one is A5. How far up does it go? Okay, so A5 is broken between those 2. And no, that was A4. A5, fine. And A7, fine. Hopefully that was it. This one is RAS, so it should be connected. Oh, wow. So this one is missing right here between those 2. What a poor job I did. And this is right, and then this is data in, so that's unique, and that's not connected. Wow, so we have to restore 3 tracks. And that was the main point of this video. This made the point for me very clearly, which is these tracks on the Amstrad are very delicate and it's very easy to break them. So this is a quick way to check those. So I'm going to go ahead and make those connections in the back. I suppose I should do the same connection. I should do the same checks in here just to make sure that everything is fine. And if, okay, that one is not supposed to work. So far, so good. Okay. Okay, here we have a broken one. How far? Oh, okay. All right, I'm gonna zoom in this one. Well, let me finish first. So that one's that. Okay, that one is fine. That one is unique. Okay, so really it's just this one. And this is what I'm in. Let's zoom in here. And so we are talking connection between, let's see, this and this. I mean, if you look at that or that, they are, I mean, there's nothing obviously wrong. It's just that those little tracks are extremely delicate and they're very, very easy to break.
For some reason, that has never been an issue for me on the Commodore 64. Looking at it closely, it looks like the tracks are a little wider, especially around the eyelets, so maybe that's just enough to prevent them from breaking so easily. Same thing on the Spectrum, it just never happens, even though the eyelets are pretty fragile, and they're easy to pull apart when you're desoldering one of those chips. But the tracks themselves don't usually break like they do on the Amstrad CPC 6128 specifically.
So there you go. I put those wires making those connections, and yeah, it's not the prettiest thing, but they're pretty small and they're underneath the board, so they should just not get in the way. And, you know, they're soldered in, so they're pretty sturdy. So I've checked that the connections are correct, so let's give it a try. Okay, let's try it. And there you go. So that was it. Just those silly little tracks that break so easily. Okay, well, the rest should just be a matter of putting the sockets back and putting all those chips and then figuring out which of that huge pile of chips that I desoldered were actually faulty and maybe salvaging some of those. But that's a pretty straightforward one. I just wanted to highlight that in this video. Once we made those fixes and also had to fix the ROMs because they were faulty, everything in the Amstrad started working correctly. I suspect somebody put in 12 volts on the 5 volt input and it just blew up everything. They must have even left it for a while because the RAMs were bad, the ROMs were bad, so much destruction going on that board. And then those really annoying cracks or damages to the tracks caused a lot of those signals not to propagate correctly. So everything seems to be good now. So let me know what you think of this format in the comments below. If you like it, I'll continue making more of these as I make repairs with some interesting parts to them. Again, these are not going to take the place of full-blown episodes. Those are going to be reserved for now every other week. Anyway, if you like it, please give it a thumbs up and subscribe to the channel. Until next video, see you then.
If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support the channel and allow me to continue making more videos, but you also get some extra perks like early access ad-free videos and more. Thanks again to all the supporters. See you next time.